In previous practical of MET, we have studied the two practicals, that is installation of CCTV, installation of UPS. And today's practical will see how to test the performance of stepper motor and how to identify various ICs using IC tester. These two practicals will be performed. Now, stepper motor. I think, do you know about stepper motor? Stepper motor. See, stepper motor is a motor which rotates in step. So, if I show you what is exactly stepper motor, let me share the screen. As you can see, here you can see this is a stepper motor. Stepper motor is a motor which rotates in step. As you can see here, it is written 4 pole 1.8 degree. When you actually give the excitation pulse to the stepper motor, it rotates by exactly 1.8 degrees and stops. So for again next 1.8 degree rotation, it requires next excitation pulse. It is not a DC and AC motor that continuously runs once you give the supply. When you give the supply once, it will rotate by 1.8 degree. For again next rotation, you have to give 1.8 degree rotation. Likewise, for each excitation, 1.8 degree will rotate. So when you give 200 rotation excitations, then complete one cycle will be rotated. Like this, you can see here 4 poles are there. Pole number 1, 2, 3, 4, and the gears are there like this. When you give excitation to this and this winding, stepper motor will rotate by clockwise direction. After this first pole, when you give excitation to the second pole, again it will rotate by 1.8 degree in clockwise direction. Okay. Again, see, this is a animation. See, first excitation, second excitation, third excitation, fourth excitation. So continuously when you give the excitation like this, your stepper motor rotates in step in clockwise direction. For anti-clockwise direction, after giving excitation to coil number 1, you have to give excitation to coil number 4, coil number 3, coil number 2, coil number 1. So in this way, when you give excitation in reverse order, rotor or the motor, you can say motor, rotates in anti-clockwise direction. So it depends upon you in what way you are giving excitation. Again, in full step sequence also you can give excitation, in half step sequence also you can give the excitation. No problem. Okay. So as you can see, the different kinds of stepper motors are there that are shown over here. This is the side angle of the stepper motor. This is a rotor which rotates actually, and here the windings are there. You can see 4 wires are there for 4 coil and 1 neutral cable is there. Okay. So for each excitation, the stepper motor rotates. As you can see, these are the windings. This is the gear which rotates. I hope the internal structure of stepper motor is clear. Now we'll see how to test the performance of the stepper motor. As you can see over here, this is a stepper motor and 2 Hz frequency is given. This is the digital oscilloscope function generator is there. See, this is frequency 1. 1 Hz frequency is applied to the stepper motor. Frequency will increase by 2. Frequency increases the speed of stepper. As you can see, it is rotating steps. It is rotating, again stopping, again rotating, again stopping. As you can see, frequency is 4. The speed of rotation is increased. As this frequency goes on very less. And as I go on to 60, see this is 20 hertz, see the speed of rotation. As the frequency, this is 50 hertz frequency, correct? 70 hertz, 80 hertz, 90 hertz, 100 hertz. See, in 100 and 200, very big difference is there. See, speed is doubled almost, third. Actually, the video is so fast that it is unable to show over there, but it is rotating at very high speed. So this is half step. So as I told you, you can rotate stepper motor at an angle of 1.8 degree or at an angle of 0.9 degree. So it depends upon you how you are rotating stepper motor. If you are rotating in if you are rotating in 1.8 step sequence, it will rotate at faster rate. When you rotate at 0.9 degree rotation, stepper motor will rotate in half speed. So in this way, for each excitation, how the stepper motor rotates, you can see actually. So again, I'll show you from the start. As you can see over here, frequency of 1 hertz, here it is applied. You can see over here, 2 hertz frequency, the speed of rotation is increased slightly. When it will be 3, speed of rotation increasing a bit more. 4, the speed of rotation is increased. See the 5 value, speed of rotation is increased. 6, 7. As the count is going on increasing, see from 10 to 20, speed is doubled almost. 40 hertz, 50 hertz. So number of excitation you are giving, actually the speed of rotation will increase. Due to buffering actually, the video is not clearly seen over here. If I show you on my screen, on my video camera, you'll be able to see the video. Is it visible on my video? Not screen sharing. See the video that I'm showing through camera.
Yes, sir.
Okay. So see, let me pin my video. See the video. See the speed of motor. It is increased in larger values. So depending upon this frequency, when that frequency was very less, 2 hertz frequency was there. See the speed of motor. It is rotating at very lower rate. It is visible in screen sharing as well, on video as well. See now the frequency is 10 hertz. See the speed. See, it is now 100. Now from this point onward, see the video that I'm showing through my mobile phone. Is it clear? Is it clear?
Yes.
Again, you can check the torque of your motor as well. See, these are different types of stepper motor, and it counts the value in kgs. Means the amount of, see, this is the torque revolution graph. Each motor has a different angle of rotation. Means some motor rotates at 1.8 degrees, some motors rotate at 0.9 degree. It depends upon your program, what you are writing. So if one motor is able to rotate 3.2 kg, means obviously torque is greater. If one motor is able to rotate 5 kg, then it means its torque is of larger value. So see, this is the bigger one motor, this is second bigger motor, this is third bigger motor. Number of windings of this coil will be different, number of windings of this coil will be different, number of coils of winding will be different, okay, for each motor. So because of that, the weight handling capacity of each motor will be different. So 4 wires are there. This pink wire, blue wire, white wire, and yellow wire. So on each wire, you can give the excitation so that motor will rotate. See the current flowing through that motor is showing over there. See, once the excitation is given, you can see this motor is lifting something. Na? We are finding actually its weight handling capacity. So at what weight? See, I'm showing it here again. See, we are increasing the weight. Still the rotor is not rotating. Means it is bearing that weight capacity. Now we are increasing the weight again. At one point of time, the motor cannot bear that weight. So see, that motor is slipped. Science. See the weight. So this motor is nearly handling 3.2 kg. So the torque it is generating, that torque is about 3.2 kg. So the amount of weight we can check now. It is about 3.5 kg. So that amount of torque this stepper motor generates. Is it clear? Is it clear?
Yes.
Okay.